Good morning all. Now we'll move to the last portion of our syllabus, the second portion of the sixth module, which is the stability of slopes. Now you can see a picture to the top right corner where there's a soil mass getting failed and there's a failure surface marked here, right? So that's a failure of a slope. Slope is nothing but an unsupported inclined surface, right? A surface which is inclined and which is unsupported. That's a slope. Now, this is one particular area where the geotechnical engineer or civil engineer in general faces quite a lot of challenge. Since our college, MA College of Engineering, is situated at the entry gate of the foothills of the high range, Kodamangalam, you can take a look at the nature of Earth towards the Munnar side, right? You can, if you're interested, you can take a visit, you can take a travel from Kodamangalam to Adimali to Munnar, and you can see to either side of the road there will be a slope. Usually these slopes are not supported, which means they are on its own inherent surface. And this poses a challenge, especially when there's a quite high monsoon intensity. You would probably remember back in 2018, just 2 years back, there was a very infamous flood and a high intensity rain. During these times, at least a few slopes, at least 3 in number, had failed in the Kodamangalam Adimali Munnar route. Now, this was in fact a particular challenge for most of the geotechnical engineers who were focusing on sustainable development. Now, these slopes, they can either exist naturally, which is the one that we were talking about now, the natural slopes, or these can be slopes which are man-made. For instance, the railways and the highways are constructed on embankments usually, which are filled and they'll have a slope. Now the canals or aqueducts, the canals which are constructed by cutting the earth has got a slope as well, right? So that's also a slope. Now these two things, embankments and canals, are usually man-made, whereas there are different slopes which exist naturally as well. Now the steeper the slope, the less will be the earthwork demanded. If you're able to cut a very vertical cut, the earthwork involved, the mass of the soil that you take out, will be very less, right? So the steeper the slope, less will be the earthwork. But once you go steeper, there will be a higher chance for it to be unstable, right? So less will be the stability. Now to balance this concept, to balance the stability and economy, we as civil engineers are interested in the steepest slope which are safe and economical. Now slope failures in general are usually downward and outward movement of soil mass by sliding. You can see the picture. You can see that there's downward and outward movement of soil mass by sliding. That is a usual trend of slope failures, downward and outward movement, and it occurs broadly by 2 things. Number 1, the shear stress of the soil or shear stress induced on the soil is increased, either due to water or load on the structures above it, etc. Case number 2 is the shear strength of the soil is decreased, either due to pore pressure or due to shaking of the land, right? So fundamentally 2 things. 1, the load on the slope increases. 2, the strength of the slope decreases. Now, for the purpose of theory, you can have divisions of types of slope failures. Number 1 is rotational failure, where the failure occurs by rotation along a curved surface by the downward and outward movement of mass. Now this rotational failure can further be divided into 3: toe failure, slope failure, and base failure, which I've tried to represent in these 3 figures. So toe failure, base failure, and slope failures are considered to be part of a rotational failure, where you assume the soil mass to fail by rotation along a curved surface. This is a toe failure, this is a slope failure, and this is a base failure. In toe failure, you can see that the failure surface, which I've marked in dotted lines, is passing through the toe, right? Whereas in base failure, the failure surface goes well beyond the toe and it reaches this baseline. Slope failure is somewhere above it. It's not reaching the toe. Now, the second broad classification is a translational failure, where, unlike the rotational failure, there's no part of rotation involved. Instead, the slope of failure surface is constant to a great extent, like this, usually parallel to the slope of earth mass. You can see the failure surface is not assumed to be a part of a circle. Instead, it is somewhat parallel to the slope line. Such failure surfaces are called translational failure. Now, there's another thing called a compound failure. As the name suggests, it's a combination of the above two types, and it's usually seen when a hard stratum exists at a considerable depth. Right, this is a compound failure. Failure surface try to attain a rotational failure, but it's switched to a translational nature and goes all the way up to the ground level. So this can be considered as a compound failure. It's a combination, rotational and translational. Now the last type of failure is a wedge failure, where there's a wedge like this. The soil mass is not rotating, it's not translating, instead it acts as a wedge and moves downward. So the failure occurs along an inclined plane, quite like a block movement. Now, before we go much deeper into the analytical part, let's try to understand the basics of physical action behind the slope failures. Now, I've written it as a balancing act because it is in fact a balancing act of a driving force and the resisting force, or a balancing act between a force that promotes the downward slope movement of material and a force which resists the movement, right? Now, when the driving forces, or the force which tries to fail the slope, overcomes the resisting force, the slope is unstable and it results in failure. Now, the usual and the most popular driving force is nothing but the gravity, right? Every slope will have a weight of its own, and it will have a component which tries to drive the slope downward. And the main resisting force happens to be the shear strength of the soil. So, whenever the force which tries to fail the surface is greater than the force which resists the failure, there will be a slope failure. Or in general, when the force due to gravity is greater than the shear strength of the soil, slope failure tends to happen. Now we'll take these forces individually and try to understand it deeper. The driving force. Apart from gravity, water can be a driving force, where in form of river or wave action, etc., water tries to erode the base, removing the soil, which might induce slope failure. Or another action of water is that it adds weight to the soil. We know that the bulk density is smaller compared to the saturated density. Same principle gets applied here. When water goes into the soil, the weight of it increases, thereby the force due to gravity increases. Now the resisting force are nothing but the shear strength of the slope material. Again, it can be cohesion and internal friction, C and phi, which is defined by Mohr-Coulomb equation. C plus sigma tan phi is equal to toe shear strength. Now, factor of safety is equal to the resisting force divided by the driving force, right? In our general case, shear strength is the resisting force, and in general case, the action due to water and gravity is the driving force. So the ratio gives you the factor of safety. Higher the factor of safety, higher is the strength of the slope. More will be the chances of safety. So factor of safety should be at least 1.5. Higher the factor of safety, let's say if you have a slope of factor of safety 3, it's the best. Now what actually upsets the balancing act? Like we said, it is essentially a balancing act between the driving force and the resisting force. So which are the components which might actually upset the balancing act? Number 1 is intense rainfall. 2018 was an example. Number 2 is a change in water level. Number 3 is a seepage water flow. And number 4 can be volcanic eruption. And then you can have earthquake shaking, or even human activity like trying to play with nature, trying to excavate soil from the base of a bridge, etc., etc., is human activity which might try to induce failure. Now these are the forces in general which tries to upset the balancing act and induce slope failure.